Hi.
Morning.
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 Howdy.
Morning. What do you guys want to do today?
That lab,
Which one?
8,
No.
darn.
Um,
I had a question about the chapter 6.
chapter 6, what? Homework?
No, it's just the overloads. A question about something that I see at work, and it's not in here. If you have a second,
What is it? I guess it depends on the question.
shunt overloads.
Mm-hmm.
Where do those fall in at? Are those
Um,
heaters, or are they
if they're overloads, I would assume that they're thermal. So yes.
okay?
But I don't know without looking at it. Are they built into the motor?
They have a set of contacts. Yeah, they're wired into the motor,
Mm-hmm.
but I'm wanting to say that you have to wire them remotely, so they're not at the actual relay, or they're not at the contactor or motor starter. If that makes sense.
Mm-hmm.
But the much older motors, they're like that.
And is there a nameplate or anything on there it should tell you that it's built in, and it might give you some more information on it. But are you trying to see if if an overload is bad?
I'm
Or
trying because when you go to ohm it out,
mm-hmm.
and I've noticed, and I've talked to another technician about this, depending on the ambient temperature, it'll give you a different reading. If in the wintertime when we go to ohm it out, it looks like the resistance is a lot lower than it is if it's 80, 85 out. Of course, in the plant, if it's 85 degrees out, it's like at least 102 inside.
Yeah. Well, I mean, resistance does change with temperature, no matter what. But
Okay.
I guess it depends on how much it's changing. Is the motor
Yeah.
bad and you're trying to fix it?
It's not it's not bad. It's whenever we have to put the GE and the Westinghouse in, the really, really big ones, we have to check it first. And they have a very loose set of guidelines that nobody's actually been over. So one of the guidelines is to check the shunt inside the motor and see if it's good.
Yeah.
And
Well,
but
for
they
that
don't,
thing,
like, their range is
I would use a Megger.
okay.
I wouldn't trust just a meter. But if that's what the specs call for
Okay.
in your maintenance sheets, then you just check ohms, I guess. But
And the electrical engineer says they don't use those anymore in the larger motors, but when they do have something similar in the larger motors, they call an open Y system that actually produces electricity as the motor runs, and the feedback electricity is what they gauge how well the motor's running by the electromagnetic field that's produced. It has an open, he called it an open Y winding inside the motor that's wound into it, and
mm-hmm.
it produces voltage back to the system, and the system decides whether the power quality like if it's running at the right,
Yeah,
efficiency.
yeah, that makes sense.
Okay. All right. He said that they don't use shunts anymore, and that this is the first place he's ever seen that they use motors old enough to have them. I
Hmm.
was just wondering if they work like through resistance and open up, or I don't know. He didn't really classify them. I didn't think to ask when we were looking at them, but all right. Do you typically see three-phase motors with overloads embedded in the motor? Or is that usually a single phase thing?
I don't recall seeing that in the field anywhere.
Okay.
Okay. Today we're going to practice this stuff. So,
What stuff?
9-lead, 3-phase motor hookup.
Okay. Why? Why?
I know I'm getting really stupid about this, but it's fun. Okay, I need a volunteer.
Okay.
Pick a number between 1 and 4.
2.
Garrett, pick a number between 1, 3, and 4.
4.
Justin, 1 or 3. Tyler, 1 or 3.
1.
Okay. So Tyler's going first, and he's going to hook up a Y low. Okay. You probably have no idea what that means yet, but that's okay because I'm going to help you. So Tyler is Y low. Hang on a second.
This is like we did yesterday.
Yes, sir. But I got a motor in front of me.
Oh shit. Okay. Because with the low voltage, don't you connect? You jumper 4, 5, 6, right? And 1 and 7 and 2 and 8.
I don't know.
Oh, okay. I know.
All
Yeah,
right.
that's
All right. So Tyler is your Y low. Tyler's Y low.
mm-hmm.
Let me get situated here. Okay. Can you see my camera and this stuff over here?
Yes.
Hello. Oh, look what I have. It's a motor.
The peckerhead
Where's the peckerhead?
right there.
Right here. Peckerhead number 1.
Numero uno.
Look if there's a way. There we go. There we go. So pay no attention to this over here. I'm going to tell you what your voltage is.
Okay.
And you're going to tell me how to hook this thing up. So Tyler, you have a Y wound motor and low voltage. So it's 208 3-phase. And I'm gonna go black, red, blue. Give me a second here. So I just ran my seal tight up to the motor and I got 3-phase. Pace.
That was nice.
That was straight magical.
All right, so the first mistake we're making is that we're not pulling in a ground. But everybody knows that we're going to pull in a ground and we're going to hook it up to this here wire that's bolted to the frame of this motor. Why are we doing that? Or why are we not doing that? But we should do that. Why should we do that?
So that the stair gets grounded.
Why do we want to ground it?
So we don't shock the shit out of ourselves.
Yeah, to protect all this wire, right? So look inside there. You can see inside that, in the hole inside the peckerhead, you can see those windings.
Mm-hmm.
The copper, those are the motor windings. And you can see how tightly they're wrapped around each other and everything. It's a pretty snug fit inside of this case. So what happens if one of those windings touches the metal case?
Well, if you're ground, go ahead.
If it's
It
properly
gets
grounded,
grounded
what's it
and
gonna
the
do?
whole thing. Never mind.
If it's properly grounded, it's going to trip a breaker or a fuse.
If it's not, the box becomes hot.
Right. So if we ran PVC to this thing and this whole thing is electrically isolated, so it's not grounded at all, this thing is energized. The motor may or may not still run, but if somebody comes up and touches it, then you get zapped. So first thing we're going to do when we hook up a motor is hook this up. The next mistake that we're making today is that I, for the sake of time, am just going to use wire nuts. We should never, ever hook up a motor with just wire nuts. What you do to hook them up, I don't have any with me right now, but do you know what ring terminals are?
Nope.
Okay, remind me when I'm done talking to show you what ring terminals are, but it's just a crimp-on terminal that you would crimp onto the end of these things, and it's circular shape, so you can fit a bolt through it. So if I was hooking this wire up to blue, I would have a ring terminal on both ends. I would hook, tighten it together with a bolt and put mastic tape around that, and then 33 plus or 130C. You just take your time and you overdo these connections and you tighten them up with the bolt, because this is an area that you don't want things to fail, and these wires are going to get hot. They're all packed in here pretty closely, so if you're just putting wire nuts on there, there's a real good chance that over time stuff in here is going to burn up. And then if these things get burned up, like let's say this wire number 7 insulation got burned up way down in here, you're kind of screwed, right? Because this goes directly into the windings. So you'd have to take this motor apart and re-tap the windings with a new wire. So that's why you take your time and you make really good connections with these in the field. But for the sake of just hooking up, practicing this 9 lead stuff, I'm just going to throw a wire nut on there. So I've got black, red, blue coming in. Do you think there's a reason I chose those numbers, those colors?
Yeah.
Why?
No idea. I just know there's a reason.
Well, I would say black is because it's the negative side. Red is because it's the hot side. The blue, I have no idea.
I thought if it was low voltage, it was brown, orange, and yellow.
No. If you see brown, orange, yellow in the field, that should mean that it's 480.
Okay.
If it's 120, 240, 208, that's black, red, blue.
Okay. So the third phase is blue.
Yeah, if you see brown, orange, yellow in the field, you need to be really careful because that's 480 or 277.
Yeah.
Right?
Yep.
So that's just a little side note. You won't be quizzed on that or anything, but it is important to know the color, the standard color codes. Now, that being said, this is a black wire. Do I know for sure that it's 120? And if I touch it, it's going to hurt a lot, but it probably won't kill me depending on where the current goes through my body. Should I assume that?
No.
No, because whoever was in the panel or whoever was hooking this up or whoever ran it might have hooked it up to 480. You never know. So, all right, that's my dumb safety spiel for today. Tyler's doing a Y low. So how do we hook this thing up? Forgetting the ground.
You connect 1 to 7, then 2 to 8, and 3 to 9.
Y low?
Yes.
Okay, so I don't know. Let me. So here's Tyler. Explain what you're doing. You're going what?
I'm going from not really on the Y low. I'm starting right where the low voltage thing is, the 6. So I'm going, if you put your cursor at the 1, I'd jumper from the 1 to the 7. And then if you put your cursor at the 2, I'd jumper from the 2 to the 8. And then, the 3 to the 9. And then 4, 5, 6, jumper them together. Correct?
Yeah, very good. But how did you know that? So what are we doing to these windings over here?
I really don't know. I really can't remember. I just it's kind of like
So low voltage is parallel, right?
Yeah.
So we're going to take this and parallel it with that. Or we're going to take this and move it right next to that one.
Okay.
Right?
Okay. And why do we do that? Can you explain one more time why it's series and parallel real quick?
It is if this Y configuration is how those motor windings are hooked up in the motor, think about it like a voltage drop is the way I think about it, or a transformer. So with a higher voltage, you need more windings or bigger copper.
Okay.
To step down the voltage. So we have lower incoming voltage, so we don't need to series these. You know what I mean? Think of it this way: if I had a meter lead here
Mhm.
and a meter lead here, and I'm just checking resistance. If I hook these two up, I'm going to get more resistance than if I took them and paralleled them, right?
Correct.
Because you have a longer set of copper then. But if I took this and hooked it up there, and this and hooked it up there, paralleling them, then I would have way less resistance.
Okay.
We can actually try that with our motor if you want to later.
Let's do it.
You want to? Okay.
Yeah.
Where is mine? You will get more into this in troubleshooting, but I'm going to check the windings. So if I'm looking at this right, and this is a Y connected motor, and you are correct, Y low. You see the drawing, it matches what we have on the screen, right?
Yeah.
But if this is how it's hooked up inside the motor, 1 and 4 should be connected, right? If I should have continuity between 1 and 4. So I find 1, here's 1, and here's 4. So I'm just going to check continuity between those two. Oh, there's 4, and then this will be 1. 13.4 ohms. So somebody,
Well, that's no good. Throw it out. New
that's
motor.
bad. That's bad news bears. So 1 to 4 is 13.3 ohms.
Are you able to check when you hook 4 and 7 together? Is there any way to check through that winding, or do you have to go through 2 sets of windings?
Well, how it sits right now, 4 and 7 are not connected, right?
Oh, yeah.
Right
So
now,
you-
I'm just going to go 1 to 4. I'm going to go 7.
to 9.
I guess we can't because that's interconnected. But yeah, let's use 9.
But
And
you,
here's the thing. All of these should be the exact same resistance, ideally, between one winding. So if 1 to 4 is 13.2 ohms, 7 to 9 should be how many ohms? So think of it as 2 sets of windings.
26.4.
26.4. So we checked this. Now we're going to check this.
Oh, okay.
So 7 to 9. 7. Nine. 24.4. Close enough. So 7 to 9 is 24.4. So what should we have between from 1 all the way to 9?
Holy crap.
We should have 24.4 plus 13.3.
Yep.
Right?
Yep, 37.9.
So we're guessing that 1 all the way to 9 would be 37.7.
So, yeah.
That's our
Around there.
guess.
Oh, is that ohms?
Yeah.
I thought in parallel you had to add the reciprocal.
Yes,
that
but
was a
we're just I'm just going to series them right now.
Okay, I got you.
See what I'm saying?
Yeah.
So we're guessing 1 to 9 would be 37.7. So I'm gonna take 4 and 7 and hook them up together. Or come on, 7. Where you at? Oh, it's in my freaking hand. Don't laugh at me.
I'm not. I'm laughing with you.
Yeah. You guys are mean. Okay, so what I just did on here was made this connection. Makes sense? So from
Yeah.
checking from 1 all the way to 9, we're guessing that we'll get 37.7 ohms. So I'm on 9 with one lead, and I need to put the other on 1. $36.4. Pretty close.
Yeah.
Okay, so like Justin was saying, let's check if we parallel 2 windings. So for this one, I'll use 1, 4, and 2, and 5. So 1 to 4 would be 13 to 3. 2 to 5, I'm guessing, would be the same. So what would be the resistance if we parallel them?
If you ran them in
It'd be
parallel.
the product sum deal, right?
Right.
What is it? So 13.3 times 2 divided by, no,
So you gotta do the reciprocal first, right?
When you're only doing 2 resistances, you can do it differently than
Yeah.
if you're doing more.
We only have 2 of them. So you can do product over sum, right? Am I thinking about that
Yeah.
right? So 13.3 times 13.3.
Over 13.3 plus 13.3.
Right, which would be 26.6.
Yes.
And does anybody have a calculator handy?
Yeah, I got one.
So what does that end up being?
It's 26.6.
No, 13.3 times 13.3
Yeah.
Divided by 26.6.
divided by 26.6.
Okay. 6.65.
So we're going to say if we parallel those 2 windings, we should have 6.65 ohms
Theoretically.
theoretically. Let's do it. So I'm going to take need some spare wire here. By the way, this is already like if you would troubleshoot a motor, you could do this too. All those windings should be really close in their ohmic values. Keep that in mind for the fall. So what am I doing? 1 to 4 and 2 to 5. So how are we paralleling them? 1 would go with what?
2, right?
2. And then 4 would go with 5, correct?
Yeah. And then if you put your leads on them, yeah, that should be parallel.
So I'm just putting a little jumper on here to put my meter leads on.
Yeah, you're good.
So if I hook this up, theoretically, we should get around 7 ohms. See, Tyler, aren't you glad you asked?
Indeed.
$7.3. I love it when theories work.
Yes.
Makes sense, right? Everybody understand that?
Mm-hmm.
Okay. So let's go ahead and hook this up how um, Tyler should. So Tyler's doing Y low. That means he paralleled them. So he went like this. Bloop. 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 Right? So tell me where you want my wire nuts. Where do you want me to do this?
Put it on 1 and 7.
1 and 7. There's 7. There's 1.
Hey, and you said I spaced out a little bit when we were talking about that. You said that don't use wire nuts, right? It's just for example, right?
Yeah, this is just for
Okay.
example. Could I hook these up with a wire nut and make it work? Yeah. Matter of fact,
Yeah.
I'm going to hook it up on the trainer behind me with wire nuts.
Okay.
But it's not, definitely not proper. All right, so I could put a wire nut on this, but I'm forgetting something. Any idea?
Mm-mm.
Where
I
did
know.
black, red, and blue come into play?
You hook up without them, you got no power.
Yeah, so this is incoming power. This is our 208, black, red, and blue. So for me, black would be 1, red would be 2, and blue would be 3. So we need to hook incoming power up to this as well. Tyler, does that make sense?
Yeah.
So what else should we include in this wire nut?
Put the black with it and wire nut them all 3 together.
That's right. That's right. That's right. That's right. When you're right, you're right.
Decent.
Okay. What's next?
And repeat the process with 2 A and 2 the red. We get the red wire, and then 2 and 8.
And what's next?
3 9, and then the last wire, blue wire.
Three. Nine. Blue wire. What's next?
And just 4 5 and 6.
Hey, look, that's what we're left with. Isn't that cool?
Decent.
Decent. So Tyler just hooked this motor up for Y-low operation. And this is a Y connected 208 480 volt motor. So if I brought 280 to this, if I hook these up to 280, this motor would spin. Tyler just hooked it up for low Y. Everybody give Tyler a hand. I'm not going to keep going unless all three of you clap for Tyler.
Oh my God.
All right, looks like Nick is next.
All right.
So you're doing delta low?
Yeah.
Okay, let's work through it on the print first.
Okay.
So for low voltage, how do we handle that? Series or parallel?
That would be in parallel. Low is in parallel, high is in series. So,
Right.
Parallel. You go 395 and blue.
You all remember how to do this, right? Remember I told you make these little triangles
Yeah.
One. Yeah.
and stack them. Okay.
This is the only one. This is the only one that requires only 3 connections, right? All the rest require 4 or more.
Yeah.
1, 6, 7, and red. And then 4, 2, and 8. And blue.
Okay. So black 176 7 1.
Are you sure that those wire nuts are rated for that many conductors?
I'm pretty sure they're not. Ouch. Red
Right.
2, 8, and 4.
Correct.
Two, 4, 8. And then blue would be 3, 5, and 9, right?
Correct.
Hey, that's what I have left. Isn't that cool?
That is nice. Then you check rotation and
Yep. Tyler would say decent. So Nick just hooked this up for delta low. All right, all three of you. Good job, Nick.
golf clap.
Justin, you're not clapping.
I did clap.
Oh, okay.
Thank you. Thank you.
All right, so who's next? Looks like Justin, you're doing delta high.
Delta high.
So this is a delta wound motor, and we're going to run 480 to it. So what color wire should I bring to this thing for 480?
Well, I remember hearing orange, black.
Nope.
Okay. What you got? I know it was orange.
If you're in a 3-phase panel and you open up the front cover and you see all those breakers in there, the phasing would go black, red, blue.
I said 480 there was like an orange in there somewhere.
Yep. So that'd be 3-phase 208. And then if you were in a 480 volt panel, you would see them like this. Brown, orange, yellow. So if you see this in the field, Danger Dan, put your gorilla suit on. Put your safety glasses on. We're all going to die. But I'm not pulling brown, orange, yellow. I'm just going to use these. Okay. All right.
Okay.
So we're hooking up Delta High. How do we do that?
Well, that's in series.
Yep.
So in series, you're going to connect 7 to 4.
Boom.
I thought you said delta.
He did.
I did. Why are you yelling at me, Justin?
I'm sorry. I didn't. That was an aggressive tone. I'm sorry if I bothered you with that.
I'm totally kidding.
8 to 5. 9 to 6.
And that's it. Right?
Got 3 more
No,
connections.
Well, we got the red, black, and blue.
Right. So black being 1, I would go black to 1. So
Yeah.
basically, here's how this would hook up in the field. I'm just going to use all the same color, but this would be line 1 would hook up there. So here's your 3 wires coming into the pecker head.
So line 1 would be your hot, wouldn't it?
Yep, it'd be one of the hots. And then
And then your 2 would be your ground. Yeah, and then 2 would be your neutral, right?
yep, not neutral. No,
Not neutral. Your negative. I'm sorry.
not negative either. These are all going to be hot. If you have,
All gonna be hot.
if I have 3 wires coming in here, let's go over this real quick because it's very important. On your trainer, you have a negative wire, and it's not a neutral, it's DC, it's just negative or common.
Okay.
If I'm running 3 phase of this thing, I have no neutral and I have no common, right? I just need a brown, orange, and yellow. And I'm gonna do this right so we don't get confused. But here's my 3 wires coming in. I know you guys haven't gotten much into 3 phase yet, but if I put meter leads on, I'll draw a neutral on there because coming from the transformer, you would have a neutral. We don't need one for this motor.
Or ground.
So what color would the neutral wire be for 480, 277?
Ooh. Green with the yellow stripe? I don't know.
No, it has to be gray.
Okay.
So if I have 277 volt lighting, then I would have one of these 3 colors with a gray neutral.
Okay.
Okay, so I'm going to put my meter leads on this one and this one. What would I have? Brown to neutral.
You should have. You said 270, 480, or 277.
Yep,
You should have the full thing.
277. Just from brown to neutral, I'd have 277. All right, so from neutral to orange, what would I have?
Well, they're all 3 hot, right?
Yep.
Wouldn't it be 277?
277. Neutral to yellow, what would I have?
277.
277. Put my meter leads on yellow to brown, what would I have?
You got
What
this one, Jeff.
You got who me? 277.
And line to line,
So line to line, you would have the full voltage.
480.
480.
Oh, okay. This is a 480 power. Okay, I got you.
If I go yellow to orange, what would I have?
480.
480. So you see the difference.
Yeah.
Now in the motor, I don't need a neutral. I just need those 3 hots because I'm just running 480 to it. But you're right. So what I would do is I would hook, this would be brown in that case, to 1. And I'm going to start to go through this quickly. And then orange would be this one. I would hook that up to 2. And so on and so forth. 4 to 7. You get the point by now. 6 to 9. All right. And then Tyler or Garrett, you have the easiest one of all. I'm going to hook this up for Y high. So am I series or parallel?
Your series.
Series. So how am I hooking it up?
1 goes to 7.
That's seriesing it?
Well, the diagram that I've written down, but that doesn't make any sense. It would be 4 to 7.
Yep. This would be series. If I took 1 to 7, I would be paralleling those 2 windings.
Right, right.
So 4 to 7.
And then 8 to 5.
And the last one,
6 to 9.
you just wanted to say that, didn't you?
Yep,
And then you notice about these 2
they're the same.
are exactly the same.
And then the
Very
1,
good.
2, 3s would just go to their corresponding.
Yep. So that would be that. That. Oops. You get it. All right. Let's see. That's all we had planned for today. Tomorrow we'll look at limit switches and selector switches.
Could you tell us how the selector switch works? Like
I
on our
didn't.
trainer? Because it's kind of confusing.
I did not. Matter of fact, those are brand new and I ordered them online, so I don't even know how they work.
Ah,
But we should have 4 wires coming off of them, right?
yep.
Yep.
Cool. Yeah,
So
I would. If you want to work on that, just play around with your meter and see how they make and break.
All right.
All right.
Cool enough.
I'm going to take Justin over to a breakout room. He's having equipment issues that we're trying to figure out. So if you need something, I think you can probably message me while I'm in there still.
Sounds good.
All right.
Gotcha.
Otherwise,
You guys have a good day.
I will see you guys tomorrow.
See ya.
Yes, sir. Have a good one, Zach. See you guys
Yeah.
later.
See ya.